Hello and welcome to another IB Math Speedrun with me, Vince. So today we're going to be going through chapter 6.1. Let's talk about chapter 6 first. So chapter 6 is all about relationships in space, which is geometry and trigonometry, and chapter 6.1 is some of the properties of three-dimensional space. So let's jump right in. So I'm going to assume you know about 2D space, and so we're going to compare some of the things with 2D and 3D space. So 2D space looks something like this with an x-axis and with a y-axis. And 3D space, well, we just simply add a z-axis. And normally, we add it in this direction. So this is the z-axis. And we can visualize this if you poke out your hand like this. This pointer should be pointing towards the x-axis, the middle finger should be to the y-axis, and the thumb to the z-axis. That's normally how we visualize 3D space, with all of the axes perpendicular to each other, of course, so with right angles in between them. So, we need to talk about getting the midpoint and the distance in 3D space. So, we express 3D space using, three coordinates, just like how in 2D space, we can express a position of a point using two coordinates. So, for example, this is the point 1, 1, 1, and this point here is the point 2, 2, 2. So how do we get the midpoint? Well, the midpoint of a line segment, if we draw one, the midpoint is the averages of the x, y, and z coordinates. In this case, the averages would be 1.5, 1.5, and 1.5. So that's how you get the midpoint. That was pretty simple. And in terms of 3D space, getting the distance of this line segment, well, we need to turn to Pythagoras. So in 2D space, to get the distance of a line segment, you have x and y, and you have, say, call this a squared is equal to x squared plus y squared. If we convert this into 3D space, well, it's actually adding, how do we add another dimension here? So we probably have to add z here. And so instead of drawing it from x to y, we're drawing it from z to x to y. So if this is 3D space, and we have these three perpendicular parts, and this is the segment, then we have the length here, a squared, is equal to x squared plus y squared plus z squared. Notice we don't need to cube it, it's still squared. And if you want to prove this, we'll look at the distance here. This distance squared is equal to x squared plus y squared, and this total distance a will be equal to this distance squared plus this distance squared. So yeah. Oh, sorry. So yeah, that is about 3D space. And now, apparently, we need to go over some trigonometry in 3D space. But to do that, let's give a refresher of trigonometry in 2D space. So if we have a triangle like this, and we have an angle here, then this is opposite, hypotenuse, and adjacent. So we know that sine theta is equal to opposite over hypotenuse, and similarly, opposite over hypotenuse, arc sine, which is equal to sine to the minus 1 of opposite over hypotenuse should be equal to theta. The same for cosine, cosine being adjacent over hypotenuse, and tangent, which is opposite over adjacent. So, yep, we can do this for any triangle, and that's pretty easy. So in 3D space, well, we need to consider how do we create a triangle, a right-angled triangle. Hold up a bit, it's lagging. But we need to create a right triangle in 3D space. So depending on the problem, say we have a cuboid like this, and we draw a line from one corner to the other, and we draw a line from here to the base. Well, this is actually a valid right angle triangle since this is a right angle. And so if we get this theta over here, the opposite will be this. The hypotenuse will be the diagonal connecting the two corners, and the adjacent side will be the diagonal connecting the two bottom corners. So yeah, that's how we can play around with trigonometry in 3D space. So let's jump into some questions. So I will do the, I don't know, I guess I'll do the even ones. Sure. So first we need to find the midpoint of each pair of points. And the first pair is -4, 4, 3, and 5, -1, 3. So the average of -4 and 5 is going to be 0.5. So the midpoint will be 0.5. The average of 4 and -1 is going to be 1.5. And the average of 3 and 3 is just 3. So this is the midpoint of these 2 points. Okay. Next, we have the 2 points. It's really laggy. We have 5, 2, -4, and -4, -3, -8. Okay. And so if we're getting the midpoints here, the midpoint of 5 and -4 is equal to 0.5. The midpoint of 2 and -3 is equal to -0.5. And the midpoint of -4 and -8 is -6. So this would be the midpoint of these 2 points. Yeah. Okay. So now we have to find the distance between some pairs of points. So we need to find the distance. To find the distance, oh, I'm not erasing anymore, it's just lagging. The distance between each pair of points. Sorry, I'm going to leave this open so it runs a bit faster. And the first pair is, we have 2, 3, 5, and 4, 3, 1. So we need to get the x value. The x distance is equal to 2, the y distance is equal to 0, and the z distance is equal to 4, or -4. So the total distance is the square root of 2 squared plus 0 squared plus 4 squared. So this is equal to 4 plus 16, or the square root of 20, which is 2 square root 5. So that is the distance between these 2 points. Okay, on to the next set of points, and the next set of points is -1, 3, and -4, and 1 through -3 and 4. So the x distance will be equal to 2. The y distance will be equal to 6, and the z distance will be equal to 8. So this is the square root of 4 plus 36 plus 64, which is equal to the square root of 104. So that is the distance between those 2 points. Yeah, okay. Okay, so on to the next question. So we have, where are we? 5, find the angle between the diagonal and the base. Okay. So let me draw that. I'm actually not doing every even question. I'm just doing every other question starting on the first even one. So we have a cuboid here, and we need to find the angle between the diagonal and the base. And to the nearest degree, this is 12 centimeters, 5 centimeters, and 4 centimeters. And this is the angle we need to find. Okay, so first we need to calculate more or less this line, and we need to calculate, actually we can just use the vertical line. So this horizontal line connecting the 2 corners will have a length of 13, since 12 squared plus 5 squared is 169, and square root that, 13. And so we have 13 and 4. So this theta will be equal to arctan 4 over 13. And this is equal to, get a calculator out, arctan 4 over 13. And this is equal to around 17.1 degrees by my calculator. Yeah. Okay, finally, we have this figure. Oh, we have word problem. Okay. So we have ABCDE is a square-based right pyramid with AB is equal to 8 centimeters. The point E is 8 centimeters directly above the point M. Find CA, find AM, find EA, and D. Find the angle between EA and the base. Okay. So a square-based right pyramid will look like this. The point E is 8 centimeters above the point N. So I'm going to assume this is point E. This is A, B, C, D. So AB is 8, so that also means BC is 8 since this is a square-based right pyramid. So we need to find CA, and CA is this diagonal over here. Let's draw it in red. And so that's equal to the square root of 2 times 8 squared. Since this is 8, this is 8. So by Pythag, 2 times 8 squared is square root 128, or it's 8 square root 2. Next, AM. M is the point directly below here. And so this is actually equal to half of CA. So this is AM is equal to 4 square root 2. We can also get that by getting it as the midpoint, or by getting AE and then using that it's 8 centimeters. Oh, actually, hold on. The point, actually, it's not that low. The point E is directly above the point. It's kind of hard because they don't draw a diagram. Like, I could be getting these points wrong. If it's 8 centimeters directly above square-based right pyramid, it's 8. Okay, 8 square root 2 must be correct. Yes, 8 square root 2 is correct. So is 4 square root 2 correct for the other one? Yes, it is. Okay, so it does look like this. Next, we need to find EA. We know that's 8. This is equal to 4 square root 2. So we have the square root of 64 plus 4 square root 2 squared, which is 16 times 2 is 32, is equal to the square root of 64 plus 32 is 96. So 96 divided by 4 is 6. So we have 4 square root 6, I believe, as the distance AE. Finally, the angle between EA and the base. Well, we have the height here and we have the base. So we can simply use some Pythag. We can either, I'm going to go with the root, the angle is equal to arctan. And then this is 8 divided by 4 square root 2. And so this is equal to 2 over square root 2, which is 2 square root 2 over 2, which is equal to square root 2. So we need to find 10 minus 1 of square root 2, which is equal to, I believe it is 54.7 degrees. So yeah, that's all for this speedrun. I hope you enjoyed, and I hope to see you in the next one.